And let me be crystal clear on this point. If you can muster the power to lift a portcullis up and off its supports, there is no reason whatsoever that you cannot fully open and close the portcullis repeatedly at will. The ability to raise and lower the portcullis repeatedly is the critical answer of why it was designed this way in the Great Pyramid. And once you understand that point, the full brilliance of the design becomes apparent.
This is a drawing showing the construction schematics of the Ragged Chute air plant built on the Montreal River around 1910 to supply compressed air to the numerous mines at Cobalt. The water covers these pipes at a controlled depth so that the swirling waters entering the pipes suck down large amounts of air and takes it to the bottom of the shaft, and it will reach a pressure of 125 pounds per square inch. This air is sent to surface through a 24-inch steel pipe, and from there it is sent on into the Doomer's mines in Cobalt. If the pressure rises above 125 pounds, or a little bit more, it forces this water to drop a certain amount, and then that action causes excess air and water to travel up this discharge pipe and exit into the atmosphere, which makes the blow-off that you'll see later on in the film. This is probably the last shot we'll get of Ragged Chute air plant, eh? What's this, June the 2nd today? Yeah, June the 2nd, 88. This is the blow-off after the air plant builds up pressure and it gets over its pressure. It's relieved by blowing air and water into the atmosphere. This is going roughly 200 feet in the air. The water's being blown off by 122 pounds of air pressure. We've moved up fairly close to the blow-off, somewhere within about 100 yards. 100 feet now of the valve house. This is the air line where the air comes out after being made in the underground chamber, and this is the start of its trip to the numerous mines that used to use it in the Cobalt area. If we turn slowly to our right, we'll pick up the spot where the excess pressure and water is being ejected from underground. And we'll try, I've got the camera on wide angle, we'll try and get a picture of it coming out and as it goes up into the air. Now we'll get a little bit closer. And you can hear the roar that the water makes as it comes out from the underground. You can see there the water boiling as it makes its way into the river, and this is the excess pressure being blown off into the atmosphere.
Well, say something, Bill.
Yeah, you can't hear anything here. That noise is wrong.
The Ragged Chute compressed air plant is a marvel of simplicity and rugged engineering. Through the intake heads, the water flows through a restriction into a vertical shaft 106 meters deep and 3 meters in diameter, causing air to be drawn down inlet pipes and become entrained in the falling water column. As the bubbles are swept downwards, the air becomes compressed to a degree proportional to the height, or head, of the hydraulic column. At the bottom of the shaft, the water stream hits a concrete cone sheathed in steel, which separates the now compressed air from the water. The air rises and is carried along the roof of a 311-meter-long horizontal tunnel until it reaches an inclined plenum or collection shaft. From here, the air is carried via a 60-centimeter diameter shaft to a valve house and then along a 52-centimeter outlet pipeline for distribution to the various mines in the area. The plant is designed with an automatic pressure relief system. air is allowed to vent to the surface, creating a spectacular 60-meter-high geyser that was a major tourist attraction in the area. Having no moving parts, the Ragged Chute plant required essentially no maintenance or intervention except to occasionally adjust the height of the feed heads. Furthermore, the plant operated an astounding 82% efficiency and generated compressed air that was far cleaner and drier than from mechanical compressors, greatly improving the longevity of rock drills and other pneumatic tools. Since its completion in 1910, Ragged Chute operated almost continuously for 70 years. The Ragged Chute plant was acquired by Ontario Hydro in the 1960s and continued to operate until the valve house burned down in the 1980s. Yet the legacy of Ragged Chute lives on. In 2019, the Canadian federal government announced plans to construct an updated version of Taylor's hydraulic compressor to supply compressed air to the Holloway gold mine in northern Ontario. The compressor, designed by Sudbury-based company Electral Innovation,
On February 17, 2024, I spoke to the company's president and CEO, Dr. Dean Millar. He told me the Ragged Chutes compressed air hydropneumatic plant could be revived as a suction/vacuum hydropneumatic plant with a few modifications. Oh yeah? I like to pull on the push.